So in this video, we will discuss phase rule or Gibbs phase rule. Gibbs phase rule is formulated by American physicist Josiah Willard Gibbs. Josiah Willard Gibbs published the phase rule formulation in his landmark paper entitled On the Equilibrium of Heterogeneous Substances. The outline of the phase rule is as follows. Basically, the phase rule helps us to calculate the number of independent variable that can be used to alter the system without undergoing any chemical reaction or changes and altering the number of phases under the equilibrium condition. The phase rule basically connects the number of degrees of freedom and the number of components present in the system and total number of the phases present in the system, and the last one is two external variables. The external variables are pressure and temperatures. So this is the actual formula for the phase rule, that is F is equal to C minus P plus 2. F is number of degrees of freedom and C is number of components, P is number of phases present in the system under equilibrium condition, and the 2 is actually the total number of variables, two variables actually pressure and temperatures. So now we look at the definition for each of these parameters. The number of degrees of freedom is basically the number of intensive variables that are independent of each other, or the number of thermodynamical variables that can be specified independently without changing the phases in equilibrium. In other words, the number of degrees of freedom is nothing but the number of intensive variables that can be used to alter the system without changing the number of phases under equilibrium condition. The next parameter is the components. This component is basically the number of spaces necessary to define the composition of all the phases of the system. The components can be or may be atoms, ions, and compounds. So the next parameter is the phase. Phase is basically the region of a system or material that is chemically uniform. That means within the phases, the chemical composition will be uniform and physically distinguishable. If there are two phases, the two phases can be distinguished physically, and these two phases can be the phases can be mechanically separable as well. We can separate the phases by means of mechanical process. So this is the definition for the phase. The last one is the variables. The two external variables are pressure and temperatures. So this is one of the example of the two-phase system. This is basically the steel, which consists of the ferrite phases and martensite phases. This is basically the example of two-phase system. This sort of dark region, we call it as the martensite region, and the lighter region is called as the ferrite region of the steels.